Okay. So here in the previous class for both the sections, we have discussed about all the operators, right? And among them, we have also discussed about the conditional operators, right? And the conditional operators, if you can remember, it checks equality, not equal, greater than, less than, less than equals, greater than, less than equals, or greater than equals. And if you can combine multiple statements, multiple conditions using either double AND or double OR, right? Or you can negate one particular condition by this exclamation symbol. And suppose, before going to the if else block, suppose you have two conditions, C1 and C2. Okay, now this one we can write as not C1 or not C2. This is equivalent to this one. This simply means that if there is certain condition that needs both C1 and C2 to be true, then to make that condition false, any one of them, it is sufficient to have any one of them to be false, right? So this is what turns out. Similarly, if I take C1 or C2, that means if C1, if any of them was sufficient to be make it true, then to make it false, both of them has to be false. Okay. So with this informations, now let me jump directly into the conditional statements. The structure is if, then certain condition, or maybe multiple conditions combined, then we will create a block. In fact, we create a block using the braces. Then certain statements that is to be written here. For now, let me write only this one. So this block, suppose this is the block B1. First of all, let me tell you, a block is a collection or is a sequence of statements and blocks. That means there can be further blocks within a single block. But as for example, till now all the programs that you have seen, say if I write int main, okay, a function also creates a block, and this is one particular block. And maybe you can write certain statement here, maybe you are going to declare some variable here, going to assign those variables here. Then maybe you can start another block by say if condition and so on and on. So there can be further blocks within a single block. In fact, within this block you can create further blocks. But remember, function is a special type of block that it cannot appear within another block. That means you cannot create a function within another function. But I'll describe that while discussing about the functions in the next week. So now, so in this case, the B1 will be executed only if condition is true. Okay. Now let me see an example. Whatever I am writing, consider that is being written within the main function before the return 0 statement. Suppose I am writing int a is equal to 5. Now Suppose I'm printf, say, then if a is greater than 4, printf. For now, let me provide the braces, but remember that if this block consists of only a single statement, you can omit these braces. But for the completion's sake, I'm providing the braces here. A is greater than 4. And suppose I'm writing another printf here. Next statement. Now, if you execute this, what will happen? Let me tell you step by step. First, obviously, the variable a will be declared, as you know, a space, a 32-bit space will come into the memory, and after the assignment, 5 will be the content of that 32-bit memory space. Now, after that variable allocation, memory allocation, the hello, because this is unconditional statement. Okay, this is because the statements are executed from first line towards the last line, step by step. One statement after another statement, then the next statement, and so on. It will never happen that there is some statement that executes in between, then it jumps to the some previous statement. It never happens normally, but that can be done. There is a special statement for that is called go to, but we'll come to that point later on. In normal cases, always consider that such jumps in the statements never happen. Statements will be executed always sequentially from first line towards the last line. So hello will be printed here. Then this condition, see, this is a condition, right? A greater than 4. Condition means, if you can remember, condition means that returns some Boolean value, either true or false. A greater than 4, it returns us some Boolean value, which in this case is false because 5 is not, which in this case is true because 5 is greater than 4. So this is true. Now, if this condition is true, then whatever you have provided in the two braces, this block will be executed. So A is greater than 4 will be printed. Okay. Now this block ends here. So this block execution done. Now from this line onwards, again the unconditional statement execution will continue. So next statement will be printed. Right. Now suppose rather than 5, let me make it 3. Now what will happen? Let me write it in a blue color. Now what will be the line of execution? This is the output when the value of A was set to 5. Now I'm going to write the output when A is 3. Again, this statement is unconditional, so hello will be printed as usual. Now 3 greater than 4, this condition will become false, right? And if this is false, this statement will not be executed. So it will jump directly after the block. That means at this point, whenever this condition will be false, it will jump directly here, and next statement this will be printed. Okay, let me just show a demonstration. Int and A is equal to, suppose I am writing with 5, then this unconditional statement hello, then I am writing A. If A is greater than 4, as it is a single statement, you can also provide, you can skip the braces. A greater than 4, and then printf next statement. Now observe, you can provide any number of spaces between them, doesn't matter. Those spaces are automatically skipped by the compiler. Now, in fact, spaces are always suggested to provide to increase the readability of a program. Between every logical part of your program, there should be a space. Now, let me compile this, and if I execute this, you can see that as A is greater than 4, as this condition is true, so first hello got printed unconditionally, then as this condition is true, this statement is printed, and then this statement gets printed. Now let me make it 3. And as you can see here, as this condition is false, this statement will not be executed, but this statement and this statement gets executed unconditionally. Remember, those who have studied Python previously, this does not make next statement a part of this if block. It will still be printed. To make multiple statements in Python, in fact, in Python programming language, those who do not know, I have mentioned this, that it is determined by the number of spaces. In fact, the corresponding indentation, right? The Python determines the sequence of execution based upon the indentation. But in C, it is block, or Java as well. It is block that you will have to provide. In this case only, this next stdmt will become a part of if, because this starts from this part and this is the complete block ends here. So if this condition is false, then this complete block will be skipped and it will come to the return 0. And if this statement is true, then the complete block will be executed. As you can see, that only hello got printed here. Okay, because this complete block got skipped. Now, this shows that, any question till now at this moment? Now, this shows that.
Hello, sir.
हाँ बोलो.
Sir, sir, if we, inside the if statement, if we just write 4, then
Okay.
then
If we write only 4, right? See, I have mentioned that anyway, whatever you will write here will be triggered as a condition, right? Now, if it is considered as a condition, it will be considered only true and false. Now, what I have mentioned, any non-zero value will be considered as true and 0 will be considered as false always, isn't it?
yes, sir.
So as 4 is non-zero, so this will be considered as true and this statement will be executed.
Sir,
if हाँ बोलो. हाँ बोलो. Would you like to ask another question?
Sir, if we write literally true.
To write true, the fact is, this statement is not available in C as it is. For that, there is a header. It is called stdbool.h. This header file allows you to have even bool type of variable as well, and you can use false. Yes, right. In that, because within std bool.h, this bool variable false and true, it is defined.
Sir,
Okay. Bolo.
sir, now remove that header file.
If we remove this header file, this will be a false, because true, false and bool are not declared. But if you write a program in C++, they are by default declared.
Sir, if we put that in double quotes, true.
Okay. If you put this in a double quote, true. So in that case, what it is representing is a string. And okay, first let me remove this. And a non-empty string will by default be true. What about an empty string? A string is always true. Okay, that means even if you write false here, it will still be true. Okay, is it clear? A string.
Clear, sir. Sir, how does compiler take those strings?
Okay, for that you have to understand about the array and string and pointer as well. What is being considered here is in fact the base address of the string. But why base address? That you'll come to know. But if you have already studied this, let me show that. Suppose if you are writing an array like this. Now, if you write, in fact, in the very next week, I'll start this array and pointer and function as well. Now, can you tell me, if you have already studied this, only then you will be able to answer, what str itself represents? Let me tell you, this represents the base address of this character f. That means the first character of a string. Okay, the array name itself represents the base address of that array. That means where that array is starting, and this is similar to providing this. Now, address of a variable is non-zero, isn't it? Address of a variable, because no variable
Yes, sir,
can be
non-zero.
allocated at address 0, so that will be true. Is it clear?
Yes, sir.
Okay. It will be more clear when I'll discuss about the pointer and array, and that's why I'm because these are trivial part. These if, else, for loop, while loop, these are very trivial. So I'm going to proceed through them quickly. But obviously, I'll ask all your questions. Sorry, I'll answer all your questions.
सर
हाँ बोलो.
सर वो जो आपने इफ कंडीशन के मतलब जो एक स्टेटमेंट यूज कर रहे थे तो एक टैब दिए फिर प्रिंटफ लिखे तो उसने उसको ब्लॉक के अंदर कंसीडर किए. हम लोग इंडेंटेशन नहीं यूज फिर भी क्या मतलब ब्लॉक की तरह कंसीडर करेगा ये नेक्स्ट लाइन को?
Okay, if we do not use the indentation here, right? Are you asking like this?
जो सिंगल स्टेटमेंट यूज कर रहे थे वैसे ना यूज करके तो हम लोग ब्लॉक के अंदर सिंगल.
In fact, your voice is breaking too much. Can any of you kindly decode me what she is asking? Because your voice is breaking. Can any of you kindly decode me what she is asking? Or you can ask me over the conversation part as well. You can write your question here as well.
Sir,
Huh? Your voice is breaking.
But
Sir, maybe she is
it is not
asking
available to me.
Okay. What she is asking? some of you are answering.
Maybe
as well.
she is asking that will the condition still be checked for the second statement? If we will not put braces.
Okay, if we do not provide the braces, this second the condition, this statement will not be a part of this block. That's what I mentioned.
सर
Right. हाँ
ना
बोलो.
वो जो किया वो कंडीशन के बाद जो एक स्टेटमेंट यूज किया ए ग्रेटर देन 4 और उसके पहले आपने इंडेंटेशन दिया, एक टैब दिया है, वो अगर नहीं यूज करते एकदम नॉर्मल इफ के लाइन में ही लिखते हैं, कंसीडर करेगा ये?
Yes.
सर इफ को इफ
In fact, see, let me tell you, C program does not based upon indentation. In fact, this complete program will run even like this. It may seem strange, but the complete program will even run like it will give you output exactly as it is. Okay, and if you execute this, you'll still see the same output. Okay, because indentation, C is not based upon an indentation. Till now, if you want to provide this within the same block, you will have to provide the corresponding braces. Okay, so in that case, hello will be printed, then both of them will become part of this if block and none of them will be printed. Okay, C is free of indentation.
Yes,
but we provide indentation just to increase the readability, because when in a later life, when you will write a program of some hundreds of lines of code, you will pretty soon see that readability is one of the most important aspects of the program. That's why I want you to practice it from the very first. I have seen many beginner programmers to write all the programs from this part. This is not a good practice, right? Never use that. Always provide proper amount of tabs. Tab as 4 space, and use tab as 4 spaces here, just to increase readability. Otherwise, C or Java programming language has nothing to do with the indentation or spacing. Okay.
sir. Yes, sir.
Okay. Now, so we have seen about how to check a condition, but what if we want to do something else when that condition becomes false? For that, the keyword is else. So the complete statement somehow turns out to be if condition, then certain block, else certain block. So in that case, as we know, the B1 will be executed when the condition will be true, and B2 will be executed when the condition is false. Okay. As for example, suppose if I provide else here, let me write a greater than 4. This is a less than 4, and suppose I am writing here next statement 1. Now a is equal to 3. Let me see what is going to happen, and let me write another statement after this, after block. A is equal to 3. So first this printf will be executed unconditionally, then this condition will be checked, and this condition will turn out to be false, right? So as soon as it becomes false, it will come to the else, it will come to this corresponding else block. and this else block will be executed. The rule applies same like the if block. That means if you have single statement, you can omit the braces, but if you omit the braces, only the next statement will be executed. And if you want to include multiple statements within the block, you have to provide the brace. You have to provide the corresponding braces. Now this else block will be executed, and this a less than 4 and next statement to 1, they will be printed. And after this part gets executed, it comes out of this complete if else block, and from next point onwards, whatever statements will appear will start to be executed sequentially, one after another. As you can see, first hello got printed, then this condition is false, so it came here, a less than 4 and next stmt1 got printed, and after that this after block it got printed successfully. Whereas if I provide a is equal to 5, in that case else will not be printed, a greater than 4 and next stmt got printed, but see, the else block did not get executed. So whenever the condition becomes true, this part is executed, okay, and whenever the condition is false, this part is executed. Okay, now let me show you something. We know that equal symbol is the assigns but does not check.
सर
हाँ बोलो.
सर इफ एक बार मुझे एक डाउट है सर, जैसे अगर इफ कंडीशन फॉल्स हो गई तो उसके अंदर वाला ब्लॉक अगर एग्जीक्यूट नहीं होगा, तो जैसे उसमें कुछ एरर हुआ, जैसे ये बाद में कुछ सेमी कॉलन लगाना भूल गए, तो फिर वो एरर देगा कि नहीं देगा जब वो ब्लॉक
Obviously error देगा, because even though it will not be executed, but it will be compiled, ना? It will be compiled to the corresponding assembly instruction, and it will always give you the corresponding missing semicolon error because it is against the grammar of the C programming language. See, if you can remember from our discussion of the lifetime of the C program, it is first compiled. It is first macro processing. After macro processing, it is compiled. Now, during the compilation, it follows the C grammar, rules of the C grammar. And if the program is against the C grammar, it will give you the corresponding compilation error. Okay. Now, after the assembly code gets generated, then it starts its execution. Now, missing semicolon is grammatical error. So, it will always give you error. Right. Now, while execution, it will check that, well, this condition is not false. It will correspondingly jump to this instruction. That is happening from within the assembly code, but it will not even generate the assembly code because of this grammatical error. Is it clear whatever I said?
Okay, sir. Clear.
Okay. Now, this assigns but does not check equality, right? Whereas double equal, it checks equality but does not assign. Now, if I write something like, say, suppose I have another variable b which is also set to 5 or maybe 4. If a is equal to b, obviously if I write a is equal to b, now by now you have understood that the else part will be executed because a is equal to b is false, and as this condition is false, this will not be executed, else part will be executed. Whereas a not is equal to b, in that case the if part will be executed because a not is equal to b is true, so this part will be executed. Okay, but if I write a equals b, What do you think? It will give me some compilation error? Because I have not written any condition there. What I've written here is an assignment there. Let me show what's happening. As you can see that A equals B, the if block got executed. But what happened here? The fact is, okay, before that, after this statement, let me after block print these two variables. I have converted it to conditional checking again, and as you can see, okay, mistakenly gave it here. As you can see after block 5 4, because this equality checking did not assign the value of B to A, otherwise both A and B would be 4, right? It did not assign. But let me write A is equal to B here. Okay, what will happen here? First, let me write this here. If I write if A is equal to B, then certain block, first there is an assignment operator. First, B will be assigned to A. Now at this moment, both A and B has the same value. Assigned value is returned as result. That means if you write A is equal to B, suppose int A is 5, B is 4. So the value of B will be assigned to A first because this assignment operator. Then the assigned value will be returned. So if A is equal to B, I write A and B both gets 4, then that 4 will be returned. And 4 by default is true or false?
True.
Anyone?
True, sir.
True. So that's why what you're seeing here is the execution of this statement, because this as condition becomes true because the assigned value is returned here. And that's why if you execute this, you can see that this if block got executed, and see the value of A and B both have become 4 because value of B has been assigned to A and that has been returned as 4. As a check, let me make it 0. So A will get the value of 0, and 0 means, and obviously assigned value will be returned. So 0 will be returned, and 0 means false. So this condition will become false. As a condition, this will become false, and both A and B will get 0. And if this is false, the else part will be executed. As you can see that A less than 4 next STMT1 has been executed, and both A and B has become 0. Is it clear what happens when you use assignment operator as a condition? So whenever you use assignment operator as condition, remember the assignment will happen. The value will be assigned. Then the assigned value will be returned for true or false. Is it clear?
Sir?
Yes, sir.
हाँ बोलो.
Sir, small doubt.
हाँ बोलो.
Sir, here, got at the last case 0.
हाँ
That means here we got 0 0 in the last case, no sir.
हाँ
When
हाँ.
we assign value to 0.
Hmm.
So instead of percentile D, if we use percentile S, then can we get false false?
Percentile S. Percentage is for string, but A and B neither of them are string. Remember this. True is a Boolean value. Boolean value, not string. If you write like this, it is string, but this is just like any other string, like say hello. Okay, true is a Boolean value. Similarly, false is a Boolean value. It is not string. Okay.
Sir,
Is it clear? And
once try to compile once and type yes, sir.
okay, but you will not get the result. Let me show this. What you are getting is null, because a is an integer. You cannot print that as a string. But what happened here? Why did it print null? You will understand this when I'll tell you about the pointer and array in the next week. But let me give you a glimpse. Let me show this. Suppose I am writing a string, character str, say 10 hello. The fact is, when you will print a string, use percentage, right? But what you provide is the name of the array. See, hello got printed here. What you provide is the name of the array, and name of the array means its base address.
Excuse me, sir.
हाँ बोलो.
So why is it showing null and not any error?
That's what I'm telling. Just follow the logic step by step. When you write the name of the character array, it gives you the corresponding string at that base address, right? Can you follow this up to this?
Yes, sir.
Now, what you are providing here is A and B. It will also take it as a base address, right? Like str is a base address, and it prints whatever string is written there at that memory address. Now A and B are base address as well. So as A and B you are providing here, it is also thinking with percentage, it is also thinking A and B are some base address of some string. Okay, but is 5 some, can 5 be base address of something, or can 0 be base address of something, some string? No, there is no string there. So that's what you are seeing here. Okay.
Sir, but we have already them as int variables. So sir, why is the compiler not compiling in terms of the int variables and not showing any error? Why is it taking them as a string?
Okay. What printf does is, let me show you one thing for that. Suppose what printf does is it accepts everything blindly. Can you tell me what is the expected output here? I have given 2% there, but I have written one single variable. Have you ever checked what does it give? For the next percent, it does not give you any error. What it gives is a garbage value. The fact here is, by luck, what you are getting is a 0, but because after A in the memory address there is a 0 here. But let me write B here, and let me give B some different values of 14. There is no variable after B. Well, anyway, that memory has also been initialized with 0. But what you generally get is a garbage value here, but it is not giving any error. Can you tell me why? The answer is this. Let me show you the functionality, how printf works. What printf does is, as its arguments, it first takes the string in a memory address. Okay, this is where the string is, this first string is. this after block %d and so on. This is written at this address. Now after this address, next argument. In fact, all the arguments and parameters come into the memory address. In fact, a special region of memory that is called stack memory. Now when it will print continuously, it sees %d. One pointer is pointing here. The value of a gets printed here blindly. Now it observes the next %d. See, the bytes are stored in this order, right? So this %d appears first. That means this %d appears before this %d. So this %d, then some bytes above this %d occurs. Now as soon as it sees this %d, what it will do? It will not give you any error. Rather it will jump to the next byte address. And here you are seeing luckily 0, right? Because many things have been done. In fact, many variables have appeared here, that memory have been freed and so on. But what is lying here is what we'll see by this %d. Is it clear whatever I said? Is it clear whatever I said?
सर
हाँ बोलो
सर वो एक बार फिर से बताएंगे कौन सा %d पहले काम करता है?
See, after block %d. Okay. Now let me write a smaller string, say a, then space %d comma space %d /n. In memory, the strings are arranged like this. A, that means in fact obviously its character value, that means 65 is here, then space, that means 32, then the % symbol, right, then d, what is there after that, but then a comma, then another %. If there is some space, I have not, yes, there is another space here, so there will be another space in between, and then another d. In fact, if you write any string, suppose if you write any string, character str say 10, then I am writing hello, and not only string, any array is stored into the memory one after another. Memory address increases from lower byte to upper byte, that I have discussed in class. So at first it gets, the first byte gets H, every character is a single byte, the next byte gets E, next byte is L, this is L, and this is O. And at the end there is a special character that is called null character, but I am not going into this point. This in fact represents the end of the string. But bytes are stored in this order. So it is also stored here in this order as well. So whatever I have written there after block, it was in this address A, F, D, E. So A, F, T, E, R, then space %D and %, and so on, all the way up to the string. Then after the string ends with the null character, then this variable A, this parameter appears above it. Is it clear whatever I said?
Yes, sir.
Okay, so in the memory, this %d appears below. This is the first %d, then this %d appears, and when it checks, it starts checking from the lower byte towards the upper byte. At this %d, it takes the next variable, right, as expected. So this %d, oh, it is b here, so the b variable, and for the next %d, the variable at the next memory address, or in fact the information at the next memory address, whatever is there. Okay, but if you are not passing anything here, it simply will print whatever is at the next memory address. That's it. It will print that blindly. Is it clear whatever I said?
Yes, sir.
Now, suppose you have written int a is equal to 5. Now, this discussion can become a bit difficult for now for many of you, but this will be clear when I will discuss about the strings in details in the next week. Now, if you print %s, %s, you wrote a, b, hello, sorry, str. Now, what printf function does in the case of %s is it expects a memory address. Okay, so in the case of printf, it is again seeing, in fact, %s is here, but for simplicity, I'm writing it here, %s, and obviously there are commas and spaces in between. Just above this, it is expecting some memory address a, right? It is expecting a memory address. Above this, it is looking at the bytes blindly, right? Whatever is at the next byte, you will consider that as a memory address because there is a percentage. Then above this, it is str. Now, value of a is 5. So it will try to access the memory address 5 because it will consider this as a memory address. It will not check what data type it is. Because see, at the end, it is not a that is being passed, it is the content 5 that is being passed. It is 0 that is being passed. And here, the memory address of this str may be 0x12344, where that real memory address is, this real string is present. Maybe at that memory address, this variable hello is present. At this 0x1234 ABCD. So at this percentage, it will look for this byte 5 and it will try to access that memory address 5, but there is nothing. So null. Then percentage, it will try to access the memory address 0, but there is nothing. Again null. For this percentage, it will try to access the memory address this, but at this memory address, this string is present here, and it will print that string hello. Is it clear? It is not looking at the variables. It is the values that are being passed. Okay. Is it clear to all of you? In fact, why it is giving null here?
Yes, sir.
Excuse me, sir.
Yes.
Bolo.
Sir, can some compilers show error? So because if I am checking online, sir, then it is throwing a garbage value. So but I am using Linux terminal, then it is showing wrong format.
Okay. In fact, I am also using Linux here. Okay. Can you tell me what is the version of GCC you are using?
Sir, I need to check that.
Yes, you can check that using GCC space -v. Mine is the latest one, 11.2. Now, in fact, it varies from compiler to compiler. Okay. Now, where you are seeing garbage value, because whatever is at the memory address 5, it is trying to convert that to a character and show that. Maybe at the memory address 5, originally there was some integer, say 11, maybe 2, 3, 7, 8, 9, and so on. Right? It is a byte, so 11, maybe then 120, and so on. That was in fact at the memory address 5. So whatever is showing you the garbage value is in fact showing the corresponding character representations of this. Okay. The compiler, what is showing the wrong format, is in fact is trying to show that at this memory address, whatever it is there, it is at least not a string. Is it clear whatever I'm saying? It varies from compiler to compiler. So, and the current compiler, it outright shows that null. there is no string at that memory address. It does not also show error, but it also shows that there is no string at that memory address. Is it clear whatever I said?
Yes, sir.
Okay, sir. Yes, sir.
Yes,
Well,
sir.
now,
Sir,
bolo.
sir, once show that program you have written.
This one.
For
Okay.
explanation, you have written something
Okay. Okay.
and written. Sir, this one, what you will get printed? What will be printed? Third line.
Here.
Yes, sir.
Here, as I said, maybe some compiler will outright show you the simple that whatever character is stored there. As for example, at memory address 5, it is 11 stored there. What 11 represents as character? You have to look the corresponding ASCII chart. Let me open the ASCII chart. It is very much here. At the 11, it is some virtual terminal. So obviously it's an unknown character. It is not a keyboard character. It will show you some garbage character, right? Then maybe the next character it goes is 120. What does 120 represents? X. So after a garbage character, you'll see the X. But it depends upon what is there at your memory address 5. It will be done by the older compiler, which does not use to perform some checking. Maybe later compilers will show you, as your friend has said, it will maybe it will show a wrong format. More modern compiler will outright show that there is no string there. You are searching for wrong thing. There is no string there, so it is directly showing null. Is it
Sir,
clear?
in fact, my compiler is showing that only if you assign the value of A, B, and if you use format specifier as percentile s, then only it will give null value.
Okay. And if you do not assign these values,
nothing will be printed.
yes, because as you can see here that for B on my compiler B a string, when it was unassigned, it gave me null, because B by default here started with 0. So at the address 0, as I've said, at the address 0 there was nothing. But can you try to print the value B as integer, and is it giving 0 when it is unassigned? Check it out. I think on your compiler, when the value B is unassigned, it is a local variable. Provided it is a local variable. Local variable means?
Sir, one value I am getting 0 and another is some 41555.
Yes, some garbage value. See, when you are defining it outside function, it is a global variable. Okay, global variables are always initialized with default values. That means 0, 0.0, and so on. Whereas local variables, it is completely dependent on what was at that memory space previously. It is not in your hand, or with what value it will be initialized. So the one value which is showing some garbage value, if you try to print that as a string, it may show you nothing if there is 0 at that very memory address as memory address. As for example, even at memory address 5, if there is no 11, it is 0 here. What it will show? It will show you nothing, no string, because the null character itself is equivalent to 0. So as soon as it will see 0, it will think that, well, there is no string here. In fact, a string ends here. So it will show you nothing. But you will understand all these facts when I'll discuss about the pointers and arrays in details. Okay. It will be clear then, step by step. Any other query?
No, sir.
Okay. So now let me come back to my main point. Any of you have any query regarding this if, else, and using assignment as condition? So till now we have seen if, else, and assignment as condition. Any confusion regarding this? Okay.
No, sir.
Okay. Now let me show you. In fact, let me come back to my previous part. Say 4 and let me remove B. If A is suppose less than 10, then A is of single digit. Suppose I'm writing. Now let me provide only a single statement always, because in the case of multiple statements it is now trivial. You can understand what will happen. A is less than 10, and here suppose I'm writing A is greater than 10. Now what if you do not want to check only a single condition? Maybe you want to check how many digits A has. A is of single digit. Okay. And suppose you want to let the user know whether A is of double digit or A is of triple digit, because at this moment if you execute this you will always get A is of single digit. Let me make this user input as well. Now if I provide 12, it is showing only A is greater than 10. Okay. Whereas if you provide 2, A is of single digit. So I want to check more than 2 conditions now. In fact, more than 1 conditions now. For that, the corresponding construct is else if. So if some condition, let me write shorthand now. If C1, one condition, B1, else if C2, B2 here, then suppose else if, you can provide any number of else if, as many conditions you wish, else before. So what will happen here is that if C1 is true, B1 will be executed. B1 will execute. Now here, if C1 is false and C2 is true, B2 will execute. Now see, though we have not provided not C1 and then C2, but when it has appeared under else if, it automatically means that the previous if condition has failed. Okay, and here it means if both C1 and C2 are false, C3 is true, B3 will execute, and this means if all of C1, C2, C3 are false, then B4 will execute. Okay. Now let me show this with an example. Suppose I am writing else if a less than 100, a is of 2 digits, else if a is less than 1000, a is of 3 digits, and else printf a is multi-digit. And this will execute successfully. Suppose I am writing 4, a is of single digit. If I am writing 12, a is of 2 digits. And if I am writing, say, 345, a is of 3 digits. Whereas larger than this, we give a is multi-digit. Now, what happened here? Whenever you are giving the number, whenever a is getting a value, it is first checking with this condition. If this condition is true, this will be executed. Now, it will come here only if this condition is false. I have seen many beginner programmers to write like this to ensure that both conditions are being satisfied. But you can provide, but it is unnecessary. Whenever it is coming here, whenever it is coming on this line, it automatically means that this condition has become false. So this condition is simply unnecessary. Okay. So in this case, so it will come here only if a is not less than 10. But if a is 100, suppose in the case of say 12, then it will print a is of 2 digits. Then if both this has failed, that means this condition has failed and this condition has failed as well. So both these conditions are false, only then it will come here. So if else if this else this sequence, it is executed, the conditions are checked sequentially. Okay, that means, let me show this. In this case, this will never be executed. This a is of 2 digits does not matter. Whatever input you provide will never be executed. Let me tell you the reason. Let me write this here first and you'll understand why. Suppose I am writing if a is 10, then some statement b1, else if a is less than 1000, then some statement b2, else if a is less than 100, then some statement b3, else b4. Now, if you provide suppose 4, this condition is true, so b1 gets executed. Now, if you provide 12, okay, this will become false, but see 12 is less than 1000, so b2 will be executed, and it will not even come here. It will not even come to this condition or this condition. Now, even if you provide say 134, till then b2 will be executed because it is less than 1000. This condition is true, so b2 will be executed. It will not even reach here. Sorry, it will not even reach here. Now, if you provide something say 1500, this is false. Now this is false as well, right? b2 will be false as well. It will come here, but this condition is false as well. Because if a is less than, because a is greater than 1000, it is obviously greater than 100. So this condition will not be executed and b4 will be executed. So when you will provide the if, else if, else, all these conditions, this if else if sequence, provide the sequence carefully. Is it clear? Though there is one way to allow this to execute, and suppose I am providing 23, it is giving me age of 3 digits. That means this is being executed. To provide this, you have to forcefully give the condition that if a is greater than or equal to 100 and a is less than 1000. Only then, now if you write this, suppose if I write a is greater than or equal to 100 and a is less than 1000. Now suppose 134 appears here. Then B2 is executed, correct? In the case of 12, because in the case of 134, a is greater than 100 is true, a is less than 1000 is true. Both are true. So it will be executed. Now in the case of 12, this condition is false. This condition is now false. So this complete condition will be false because there is an AND. And so 12 is obviously greater than 10. So this has already become false. This condition will also false. It will come to this condition and this will become true. And in that case, B3 will be executed. Is it clear whatever I said till now?
Yes, sir.
So,
yes, sir. Yes, sir.
Okay. So if you do not like to write such complex code, this is not complex, but at least complex than this. Okay. If you want to keep your logic simple, because anytime you will write such code, and when you will create software for open source, the reader of your code will immediately tell you that you could have changed the sequence of your conditions rather than writing such complex one. Okay, so use the sequence carefully. Okay, any query regarding this conditional statement? And one last thing that I want to mention is block within block. You can provide blocks of any depth. So if I write, say, if some condition C1 within this block, suppose I am writing if C2, then suppose B1 executes, else B2 executes. Here I am writing else, then suppose I am writing if C3, B3 executes, and else B4 executes. In fact, you can expand it in any way. That means you can provide an else if, and you can provide such if, else if, else within that else if as well. Or you can even go further deeper. That means if maybe within these cells you can provide further more conditions. In any way, you can provide any block, any if else else block within any of the another if else if or else block. You can provide any block within any block, right? So doesn't matter about that. But what will happen here if you think sequentially? If you think sequentially, if C1 is true, I am only showing one demo. If C1 is true, it will come within this if block. Now within this if block, it will start executing it again. Then if C2 is true, B1 will be executed. If C2 is false, B2 will be executed. So as you can think that if C1 is true, if both C1 and C2 are true, B1 will be executed. If C1 is true but C2 is false, B2 will be executed. That means if C1 is false, and suppose if C3 is true, B3 will be executed, and if C3 is false, B4 will be executed, right? So once it enters into a block, it starts executing normally. Like it will see any other block, it will execute that normally, and so on. Let me show a demo. The famous leap year problem, right? What is the logic of checking leap year? If year is not divisible by 100, check divisibility by 4, else check divisibility by 400. That is the rule. So if year %100 is not equal to 0, if year %100 is not equal to 0, that means year is not divisible by 100, right? Because if you divide year by 100, you are getting some non-zero remainder, so it is not divisible by 100. Now in that case, check divisibility by 4. If year %4 is equal to 0, then printf leap year. In that case, if it is divisible by 4, in print leap year, else printf not leap year. And else means this complete block gets executed when it is divisible, when it is not divisible by 100, and this block will be executed when it will be divisible by 100, right? And in the case of divisible by 100, you have to check the divisibility by 400. So if year %400 is equal to 0, in fact this complete thing will come here, except 4 will become 400. Okay, and that means what is doing here, it is block within block. If it is not divisible by 100, it will come here. Let me show each and every case one by one. Suppose I am giving, say, 1920 leap year. Why? Because 1920, it is not divisible by 100. If you divide by 100, remainder will be 20, which is non-zero. So block will come here. Now, so the block enters here, the flow of execution enters this block. Now it is another condition it checks. So year %4, is it 0? Yes, it is 0, because 1920 is divisible by 4. So it enters this block, and in this block it is printf leap year, right? So leap year gets printed. Now as this condition is true, it will go out of this else block, it will come here, and as this condition got executed, it will simply jump back here at this point, right? So it printed leap year and exited. Now if you write, say, 1921 not leap year, in the same manner, not divisible by 100, so it enters this block. This time this condition is false, staying within this block, staying within the outer block, but this condition is false, so it will come to these cells and not leap year will be printed, and this block done as well as it will come here. Now suppose I am writing 2000, year 2000, that was leap year, because in the case of 2000, year %100 is 0, so this condition is false, right? So it will come within this else block, and now within this else block it checks another block. and 2000 percent 400, that is 0 as well, because if you divide 2000 by 400 you get 5, no remainder, so leap year will be printed. And 2100, this will give you not leap year for the same reason. 2100 is divisible by 100, so else block comes here, but this condition is false, so this will be executed and not leap year will be printed. Okay, is it clear?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay, just wait for 5 minutes. Take a break of 5 minutes. We'll be back after 5 minutes. Okay. Okay. So that was about block within block and so on. Now, ternary condition. The symbol is condition question mark, then the corresponding block B1 and then colon block B2. This means is exactly equivalent to what is the case of if and else. If condition is true, execute B1, otherwise execute B2. But there is one point that you must remember. It is generally a shorthand for if and else, but never misuse this. Otherwise, the code will be unreadable. Use this only if B1 and B2 are small, preferably single line. If B1 and B2 they are only single line statements, you can use this. In fact, in that scenario, using this seems much suitable using ternary condition. Let me show this here. As for example, if year %4 is 0, then printf leap year. Let me first comment it out. Otherwise, printf not leap year. Year %4 is equal to 0, that is the condition, and if this is true, printf leap year. Now, after the colon, printf not leap year. So, if this condition is true, then this statement will be executed. Otherwise, this statement will be executed. Okay, this and this are doing the same thing. Similarly, the same thing can be done here as well. Year %400, if this is 0, then printf leap year. That means if here is not, if here is already divisible by 100, then if here is divisible by 400, then it's leap year. Otherwise, it's not leap year. And you can see that it is still going to give you same output. Okay, you can check it out for the rest inputs as well. So it is doing the same thing. So you can minimize the code. Like this. Now, the fact is we can minimize it further. Okay, in fact, we can write a very small code for checking leap year using ternary condition. But for that, I'll use a variable. Okay, before that, let me tell you. Suppose this ternary condition even works within printf, because this creates an expression itself completely. Let me show this. If suppose b is equal to 4, printf b greater than 5. If it is b greater than 5, then say greater, else lesser. It may seem strange, but the fact it will print successfully. What will happen is that b is 4. It will first check this condition. b greater than 5, this is false. So it will jump here and lesser will be printed. Let me show that. It is asking for this here, though it will be independent of that, but it printed lesser. Okay, that's ternary condition. That is the advantage of ternary condition. You can use it anywhere. That ternary condition, as long as your blocks that statements are false, those statements are small, of single statement only, you can use it anywhere, even within printf, even within any as a function parameter. Okay, in fact, what you're seeing here is what you're passing is as a function parameter. I'll come to that point later, but you can use it anywhere. That is the advantage of ternary condition, and it makes the overall code concise. Now, I'll write a code. Observe the use of carefully. Use of Boolean variables carefully. I'll decode this, but this should also, let me first check at first. Okay. Let me make it y only. Now, if I give 1921, not leap year, if I give 1920, just 1 second. Let me first demonstrate what I am trying to do here. That is doable. I have maybe garbled up the conditions a bit, but let me tell you what is happening here. Int p y percent 100. Yes. This will do now. Okay, and for this you can see leap year, and you can see this is not leap year. So what is happening here? Follow this carefully. It may seem complex for some of you, but if it seems complex, don't worry. Such things are not going to come in your exam. But those who are enthusiastic programmer or want to be a passionate programmer later, follow these tricks. Y percent 100. Maybe some of you by now has already caught what I've done here. What this statement means. See, I am using this as a condition. Now, when you use an expression as a condition, what happens? Can any of you tell me? Am I audible to all of you?
Yes, sir.
Yes.
When you use an expression as a condition, that expression is evaluated, and then that result is used as a condition. So y percent 100 will be evaluated and used as condition. Now what does it mean? It means if y percent 100 is 0, that means y is divisible by 100, it is false. Otherwise, If y% 100 is not 0, it is true. Is it clear till now? Now, if y% 100, if this returns true, then what are you doing is that not y% 4, not y% 4. Again, what is it doing? See, as soon as I am using not, it is going to take y% 4 as the boolean and then going to do its negative. So evaluate y% 4, take its true or false and then negate it. Okay, so what does it mean? Not y% 4. Okay, so if now I'm within this part, the sub part of this, because I have written it within question mark and colon. So if this is true, then this will be executed. That means if y% 100 is non-zero, that means y is not divisible by 100, then this will be checked. Okay, so now after checking, what it will be done, after executing, what it will be done, if y% 4 is 0, that means y is divisible by 4, return not 0, that means not false, that means true. Is it clear till now? And otherwise, that means if y% 4 is not is equal to 0, rather than writing this, if not is equal to 0, return false, because non-zero value means true and its negative means negative false, that means negative true, that means false. So if y% 4 is 0, it will return true. That means if y is divisible by 4, it will return true. That means there is a leap year. If y is not divisible by 4, it will return false. And here, if y% 100 is 0, it is false. So now it is coming here. This is this, and this is this. Okay. Now, if it is false, this will be executed. But here, I am going to check divisible by 400. If it is false, means when it is here, that means y is already divisible by 100 because y% 100 is 0. So y% 400 will be checked. If y% 400 is 0, similarly, its result, if it is 0, then it will return true. That means there is a leap year. Return true, that means leap year. Otherwise, not leap year. And that value is being assigned to B. So when B is true, it is leap year. When B is false, it is not leap year. Is the logic clear? Think about it.
Sir,
हाँ बोलो.
1 in minute only.
Huh?
1 in minute only in Newton.
I'm sorry, I'm not being able to understand your question, I think. Can you write it in the chat?
Yes.
Okay. By the time Mrityunjay writes the question in chat, for the rest of you, have you understood why B will be true when y will be a leap year and why B will be false when y will not be a leap year? See, everywhere I am using the result of the remainder as true or false. See, when you are using the remainder as the true or false, if it is divisible by the corresponding number, then the remainder is 0, that means false. So if you are using remainder as the true false detector, then if the number is divisible, it is false. If the number is not divisible, it is true. Okay, so if the number is divisible, it is false, right? So in that case, it is going to check divisibility by 400, and if the number is not divisible, it is true. It is going to check the divisibility by 4, and that's obvious because if it is divisible, check the divisibility by 400, and if it is not divisible, check the divisibility by 4. Up to this, it is clear. Now, if it is divisible, it is false, so not false, return true. Similarly here, if it is divisible, it is false, not false, return true. And if it is not divisible, it is true, so return false. So it is not divisible, that means not leap year, that means it is true. And if it is divisible, that means leap year. If it is divisible, that means it is false, and it is returned true, that means it is leap year. So if it is divisible, it is leap year, and if it is not divisible, then it is non-zero. So true, not true means false. So not leap year. Is it clear? Think about it yourself a bit. You will understand what I have done here. Just use the result of the remainder.
Excuse me, sir.
Bolo.
Sir, that the ternary operator will return true or false.
Yes, the condition will return true or false.
Yeah, but the B is integer, not a boolean. How it will store?
The fact is, true will become a 1 and false will become a 0 when you try to convert it into an integer.
So
Okay.
for that not 0, it will store 1, not 2 or 3.
Yes. For not 0, it will store 1. When you will convert it into a boolean, and then you will convert it back from boolean to integer. Because suppose I am writing something like this. Let me show this here then directly. Suppose I am writing int c is equal to not 5. Printf %d and c, and you will see that it is giving you 0. See, so not 5 is giving you 0. Now let me write int d is equal to not c, and let me print d, and see, it is giving you 1. So because c is false, not a non-zero value, non-zero value means true, not true means c is false, and false is int, and not false is true, and d is in that case true converted to int becomes 1. Is it clear? So B will get either 1 of 1 or 0. If it becomes 1, so in the printf I have also used the ternary operator. If it is 1, then it is leap year. If it is 0, then print not leap year. Is it clear whatever I said?
Yes, sir.
Mrityunjay, you haven't written the question, I think, till now.
Sam domain one in no show.
Oh, can someone kindly decode what he is saying? Anyone?
Sir, he is saying comment box is not working.
Okay. So, what was your question? Can you write it in my private chat? If you wish, you can ask the question in my private chat as well, in the Teams. Okay, I'll answer that. So, any query regarding the ternary operator? Ternary operator, if, else if, all these details. हाँ बोलो.
Sir, instead of not writing that exclamatory mark and exchanging 4 and 400, will it work?
No, it will not do. Let me show you why. Suppose I am writing y percent 100, then y percent 400 colon y percent 4. That's what you're asking, right? Remember again, when I write a percent b as condition, when divisible, it is false because remainder is 0, so false. When not divisible, it is true. Okay. Now, why? Now, when it will come here? When this will be true. And when this will be true? When y will be not divisible by 100. But when y, do you do this? So it's something like this. If y is not divisible by 100, check divisibility by 400. But that's not the original, right? This is in fact equivalent to this. And else, check divisibility by 4, because in the else part it is written here. So that's why it will not work. Is it clear?
Yes, sir.
Bolo.
If I use that negative sign in the condition, then?
Okay. If you use the negative sign in the condition, then yes. If you use negative sign, then obviously the completely opposite thing will do. So in this case, this negative sign is equivalent to y is divisible by 100, right? So in that case, check divisible by 400, but you have to use a not symbol here, right? So these two are same, writing this and this. These two are same. Follow the logic step by step. Int b not y percent 100. Then suppose I am writing only y percent 400 without exclamation and y percent 4. Now, if y is divisible by 100, this is what is represented by this one. If y is not divisible by 400, It is represented by this one. Then B is true. Else B is false. Right? Whereas this else is equivalent to this one. So else, as we are checking y% 4, if y is not divisible by 4, B is true, else B is false. But we want the exactly opposite. Is this clear? Why this and this are equivalent? See, not y% 100. First, let me start with if y% 100. Let me remove this. It got stuck somehow. Why it got hanged? Oh, yes. Now see, y% 100. If y% 100, then y% 400, or y%, otherwise y% 4. Y% 100 means if y is not divisible by 100. Okay, and if this is true, it is coming here. Now if y% 400 is true, if y% 400 is true, that means y is not divisible by 400. At that case, B will become true. Otherwise, B will become false. Is it clear till now?
Yes, sir.
Okay.
And yeah.
Now this one here, this one is this one. If y% 4, y% 4 is true. When it is true? When y is not divisible by 4. Then B is true. Otherwise, B is false. Okay. So what I have written here is equivalent to this one. But I want its exactly opposite. I want divisible by 400 will be checked when it is divisible by 100, not divisible by 100. So you have to remove this not. So you have to put this exclamation. Is it clear till now? Okay. And again, B has to be true when y is divisible by 400, not divisible by 400. So you have to put exclamation here. Okay. And similarly, you have to remove this not. Y have to be divisible by 4 for B to be true. So you have to put a not here. Is this clear? Now see, whenever y will be a leap year, B will be true. Whenever y will not be a leap year, B will be false. Is this clear? Is this clear now?
Yes, sir.
Okay. So that's what has been done here. If you remove the not, what I did it previously, you just have to switch these two conditions. Sorry, you have to just switch these two statements. Right? Both are same. So in fact, this is the smallest thing you can write to check leap year.
Sir?
Bolo.
Sir, we can use and or and just print it in one line also.
Yes. Yes,
Okay,
you can do that as well.
One more method.
Yes. That you can do as well. But for that, what you have to do is that int c, if y% 100 is equal to 0, and then y% 400 is equal to 0, or y percent 100 is not is equal to 0, and then y percent 4 is equal to 0. In both of the cases, it is leap year. So true, in fact 1, otherwise 0. This will also give you leap year. Look into this statement. In fact, this is two separate OR conditions joined here. What it is doing? Either this should be true or this should be true. If any of them will be true, C will be 1, otherwise C will be 0. Now, if you look into any of these two conditions, both conditions, first condition is saying it is divisible by 100 and divisible by 400, that is a leap year. Second condition is also saying it is not divisible by 100 and divisible by 4. Okay, so in both of the cases it is showing you leap year and C will be 1.
Sir,
Bolo.
sir, in fact we can reduce it more.
Yes, we can reduce it further because we are checking 1 divisible by 100 unnecessarily. If a number is already divisible by 400, it is by default divisible by 100. Okay, so that thing can be removed. Is there anything else it can be? Is there anything else you can remove from here?
No, sir, nothing else. Yes. Or else you will get nothing.
Yes.
You further remove.
For those who could not understand, let me tell you, these two conditions, among these two conditions, this condition is unnecessary because if a number is divisible by 400, it is by default divisible by 100. So this condition is unnecessary. Okay. So this will also give you leap year. So any query till now? Any query regarding? See, this is much easier to understand. This is much difficult to understand. You can follow anyone. It is, in fact, eventually at the end it comes down from programming practice to practice. That means everyone, when you will later on when you will go to the programming live, you'll see that everyone has his or her own programming style. But if you pick up any one particular programming style, follow that throughout your life. That's one thing. Until unless you see some better style later on. Okay. Any query regarding if, else, else if, nested if else and ternary condition? Any query?
Yes, sir.
Okay. So I think we can move on to from that. Just though by now you have already understood there is no necessity for that example, but still for the sake of completeness, let me show you another example, but with as small code as possible. Okay, this will do. If number is divisible by 2, first of all, if number is not divisible by 2, that means the remainder is non-zero. That means this condition is true. Odd will be printed. Otherwise, even will be printed. I think you can understand what it is by now. Okay.
Sir,
now, bolo.
Sir, that printf number 2, that will print 1 or 0, right?
Yes. Now, this one will print, yes, either 1 or 0. If this is 1, that is true. If this is 0, that is false.
Okay, sir.
Excuse me. No, switch case. This is the last topic I'll tell you today. I was thinking about going into loops as well, but can you afford another extra class in the next week somewhere, Saturday or Sunday?
Yes, sir.
Okay. All these
Sir,
extra
on Sunday,
classes. Okay, on Sunday, no problem. So now the switch case. Let me show you one particular case of if-else and where switch case is used. Suppose int a, and you are taking that as input from user. Now suppose you want to do certain thing based upon certain constant value a is going to take. Say a is equal to 2, do something else if a is equal to 3, do something else, and so on and on. Now this thing can be switched to a much easier case, but remember, this is doable only if you are checking equality with some constant or some constant expression, nothing else. Okay, that same thing will come as it is. That means int a scanf %d %a. Now switch over a, case 2 b1, then a break. This is, I'll show you why break needs to be given there. Otherwise one thing happens that is called case fall through, or somewhere you'll see switch case fall through. Break and everything, all the other cases that you have provided here, it will come one after another. And finally, if there is an else, that will do something, say b10, maybe there are 8 more conditions here, that will put here in default. Though it is not necessary to give break in default, remember this, it is not necessary to give break in default, but many programmers provide this for the for the sake of completeness, but this is not necessary. But what does break does? What do break does and what overall this switch case does? Let me demonstrate this. Before that, let me write another new file. Test1.c. Suppose I am taking the input from user. Now case 2, suppose I'm writing printf 2 a break. See, braces are not required here, but if you're writing multiple statements here, that means say if you're writing some large amount of block here, it is suggested that you provide brace to increase readability, but brace is not necessary in this case. It will by default execute from current statement all the way up to the first break it encounters. This is the trick that remember. In a break, in a switch case, execution starts from a case and executes up to first break, it encounters. Now, suppose I am writing 3 here. First, I'll write as a normal program. Then I'll change several things and I'll show you what is happening there. Let me write 2 more cases. Suppose 5 and 6. Firstly, don't think that you have to provide the numbers in sequence or you have to provide the numbers one after another like this. No, you can provide any constant here in any sequence you wish. Okay, there is no such limitations. Now, if I execute this, suppose I am giving 3, you can see that 3 got printed and nothing else. Okay, and if you print 5, 5 got printed, nothing else. So in the case of 5, it jumps here, 5 gets printed and done. Whereas if you give 9, you can see that something else has been printed because 9 did not match with any of the values in that case. So A did not find any place to jump and rather it printed something else. Now this is, so it came to the default case. Now this is one thing that you must understand. If else checks one after another. So if you write if A is equal to 2, if A is equal to 3 and so on, here A will first check with A is equal to 2. That is not true. Then it will check for A is equal to 3. That is not true as well. Then it will check for the next case and so on. In the case of switch case, it jumps to the corresponding case directly. So if you provide 3, it will not even come here. It will not even check equality with A is equal to 2. Rather, it will come directly to A is equal to 3. Now, how does it understand where to jump? Later on, you will see in computer architecture, even in algorithm, you will see a subject called hashing. Something similar happens here. What happens is that's why it is constant value that needs to be provided here. Based upon the constant values you are providing, it writes these particular blocks at particular memory addresses. Okay, and when you are providing say is equal to 3, following that same calculation, it calculates the memory address and jumps directly to B2. It does not even need to check the case for B1. Okay, or any other else. It jumps directly to that case B2. So it is happening something like this. Suppose this is the memory. Suppose, and these cases remain one after another. Suppose this is B1. The code of B1 is here, but it is at some memory addresses 0x2000. Then suppose next is B2 and it is at say it is immediately after this 2000 address, maybe say 28A5. And I have taken some, considering that this is some large amount of block of this amount of size, it comes after this and so on. Now it maps these memory addresses to these values 2, 3 and so on. As for example, 2 gets mapped to this address, 3 gets mapped to this address and so on. Now whenever you are providing A is equal to 3, it is mapped to 2, mapped to 3 and so on. Whenever providing a is equal to 3, based upon this, it is doing the calculation and calculating the address, calculating this address directly, and it is jumping directly here. It jumps directly here.
Sir.
हाँ बोलो.
Sir, what are those 0x to 8?
This is hexadecimal. Have you appeared in the first classes of this course?
Okay, sir. That is hexadecimal. That is address of a node.
Yes, this is address of this memory address of
okay,
this memory byte.
Sir,
Okay?
then a equals to 1.5. Can this also have a memory address like that?
A is equal to?
Let us say some 1.5.
That's why floating point numbers cannot come in switch case.
Yeah, that is what I'm asking.
Switch case always works with constant integers or some constant expressions that will evaluate to some integer.
So sir, we can also use characters.
Yes.
Yes, so characters
because,
also.
Yes, characters you can use because characters are integers internally. Na? When you are storing a as a character, internally it is storing 65. I'll show that. Jumps directly here in switch case. Now, let me answer this question first. Suppose I am taking character, and suppose let me change one of the cases, this one, to 65. See, or maybe just write capital A. Let me put int A here. And now I'm providing 65. See, 6 got printed. Can you check it out? 6 got printed. That means it jumped to this case. Is it clear? So eventually internally, when you are using some character as a case, in fact it is using its ASCII value as the corresponding case value. That's an integer within 127. Okay. Now, but if you use something like say 5.5 or something like that, you can see that case level does not reduce to an integer constant. It always needs an integer constant here. But you can obviously use some expression that will reduce to some integer constant. It is 5 will in fact lead you to this line. Okay. Now, bolo.
Sir, floating point is not possible, but I didn't understand why it is not possible.
Okay. There are two reasons for this. Firstly, equality with floating point is never exact. Okay. When I discussed about IEEE 75 for floating point format, I think you can remember that it truncates after a finite number of bits, right? And there I have also mentioned one thing, that it does not represent the value exactly. Okay. And firstly, floating point does not go with equality check with exactness. Okay. In fact, a bit of luck works here. The way the value is stored. Let me show this. Suppose float B, scanf %f and %b. If or maybe suppose I am giving some fixed value to it already. Suppose B is say 5.5. If B is equal to 5.5, printf match else printf not match. Oh, it is waiting for a. As you can see in this case it showed you match. Now suppose let me write some say 675 or 678. Though as I've said, it depends upon the representation it does. See, it gave you not match. Okay, so never trust an equality checking with floating point numbers, right? So firstly, if you provide some floating point number here, switch case, that floating point number case can never be reached because it can never check equality with a floating point number. And second reason is that floating point numbers cannot in fact proper term is hash, cannot hash to a proper memory address, because does not matter whatever operation you do with that floating point number, that will always be a floating point number, not real, not integer number, and a memory address should always be an integer, right? Because eventually based upon the value we are providing here, it should jump to the corresponding memory address. But in the case of floating point, it will not happen because that will never point to some memory address. Is it clear?
सर
हाँ बोलो.
सर एक केस जैसे केस 5 में आपने 3+2 लिया ना सर,
हाँ.
वहाँ पर अगर मैं 11/2 डिवाइड कर दूंगा तो रन मतलब आउटपुट 5 ही देगा ना?
हाँ, obviously. If you do 11/2 here, these both of them are integer, and this will result in an integer. So obviously, in the case of 5, eventually this became a 5 here, 11/2. Okay, because the integer division gives you integer. Any query?
So,
bolo.
So I have a query. So in the float B, the condition that you've checked for 3 decimal points, sir, it is not matching, but is there any like kind of thing that only till 1 or 2 decimal points it will match, or is it completely arbitrary?
It is completely arbitrary. That's why what we do in the during checking of floating point number, we keep a very small value. Say I have defined some value EPS as 10 to the power minus 6. In fact, this is another representation of numbers. A or any number, say 5E4. In fact, this is equivalent to 5 into 10 to the power 4. Okay, or say 6E minus 8. This is equivalent to 6 into 10 to the power minus 8. Similarly, 10E minus 6, or in fact it will be much better if you put 1E minus 6. 1E minus 6 will give you simply 10 to the power minus 6. This E is not the mathematics exponential natural logarithm C. This is exponent to the power minus 6. Now keep a very small value like this as EPS, and then you do, there is a special header file, it is float.h. What we do is that we take the absolute value of B and the number with which we want to match and check whether it is less than that epsilon value. Epsilon value means a very small, a number with very small in magnitude. Now even if B fluctuates by 1 or 2 bits in the magnitude part, while storing this 5.678, when you will subtract this number, in fact, when you will check how much far it is from 5.678, it will always come below 10 to the power minus 6. Okay. Oh, sorry, this is not provided by float.h in this version, as I can see, math.h. So here I have to use minus lm, and suppose I am providing 12. Now you can see that doesn't matter whatever appeared here, but it has given you match. This time it has matched, B matched with 5.678. So this is what we do while we compare two floating point numbers for equality.
So
Bolo.
if instead of expression, if it was just 5.678 in the if, then it'll match, right? Then it'll print match.
I could not understand your question.
So in the if condition, we're just putting 5.678 or any floating point number.
Okay.
So it'll match, right?
If you write
match
only
will
5.678, yes, because this is non-zero, so
okay,
it will match.
Okay. Thank you.
Any other query?
सर सर स्विच केस में हम लोग केस 2, 3, 4 यूज कर रहे हैं. अगर हम लोग गलती से केस 3 दो बार लिख दे और दो उसमें अलग स्टेटमेंट्स हो तो उसमें वो कैसे काम करेगा?
That will give you error. In fact, you will not even be able to compile this duplicative case value.
ओके सर, समझ गई.
Any other query? Now, what is the importance of this break?
Sir?
Bolo.
Sir, I think she was asking that if 5.678 equals to B, then also it will give a match.
In this case?
Yes, sir.
No, that's what I shown previously. This will not give you match. See, not match.
Sir, you told that you have included some special header file, sir. Then.
See, understand this thing, what I did there. Understand this step by step. Doesn't matter what I use the header file to include the function fabs function. See, if you write float b is equal to 5.678, if you try to check their equality, direct equality will always be false. Will always be false, because the bit pattern used to store 5.678 here, and when because see, after 24th bit in Mantissa it is truncated, so when it will be converted back to decimal, it will never be 5.678 back. So direct equality will always be false. Okay, what I did there is that I subtracted b minus 5.678. Okay, now maybe b can be stored as 5.6780001, right, or 5.6779999. There will be, in fact, you will get this value because of that slight mismatch maybe at the last bit or the last 2 bits of the mantissa. Okay, now none of them are exact 5.678, so direct equality will always be false. But if you subtract them and if you check that whether their difference is less than 10 to the power minus 6, this will always be true, isn't it? Is it clear whatever I'm saying?
Yes, sir. Sir,
But the fact is, it can be either greater than 5 points. That means this can become either negative or positive, isn't it? That's why I used Fab's f of minus 5.678. What it does is that it gives absolute value of b minus 5.678. So doesn't matter whether b is more than 5.678 by a single bit or less than 5.678 by a single bit, it will always give you the accurate result.
सर
हाँ बोलो
सर केस के अंदर पॉइंट वैल्यू वैलिड करेगा कि नहीं
नहीं करेगा
क्यों सर
नहीं करेगा इसका रीजन मैंने यहाँ पर बताया ना फर्स्ट ऑफ ऑल फ्लोटिंग पॉइंट के साथ इक्वालिटी कभी चेक नहीं होता है इक्वालिटी कभी मैच नहीं करेगा फ्लोटिंग पॉइंट के साथ okay floating point will never go with the equality check with exactness and secondly all the values you are passing here if they are integer constants they needs to be integer constants because eventually they will represent some memory address not the memory address directly but some expression some mathematical calculation with these values are done and the memory address of the corresponding blocks are calculated. Now, if some of them, say this, becomes a floating point number, and if you do the same calculation with that, you will get a floating point. You will get a floating point value at the finally, right? Isn't it? With a floating point value, whatever operation you do, you will get a floating point value, right? Memory address should be an integer, isn't it? Memory address, this is an address of a memory location. This can be 0, 1, 2, 3 and so on. But it cannot be a floating point number. So that's why floating point is never used in switch case. Okay. Is it clear whatever I said?
Yes, yes. ये इसके अंदर सब मॉड्यूलस भी यूज कर सकते हैं सर
हाँ
मॉड्यूलस यूज कर सकते हैं इसमें
हाँ मॉड्यूलस यूज कर सकते हो obviously. Maybe tell me something that gives you the modulus for 5 so 7% 2. You can do that because it will give you an integer constant. 5 is oh sorry 7% 2 will give you 1 not 5. What am I thinking? Say 12% 7. Now this will give you 5. Right. So you can use obviously. Okay.
Okay, thank you.
Welcome.
Sir.
हाँ बोलो.
Sir, if our floating value has more precision, then we have to further decrease our EPS value, epsilon value, no sir?
Yes. Very good.
Like,
you have understood this. You have to further decrease that. In generally, we keep it 10 to the power minus 8 or sometimes even 10 to the power minus 9. But up to 10 to the power minus 9 is sufficient. You do not need to go for that term. Okay.
So, but that is when we are entering the numbers after the decimal point up to 6 or 7 places. Sir, then we have to change our EPS value.
See, does not matter whatever you enter after decimal places. Even if you enter, say, in fact, you will know about this in very details in 4th semester when you learn about the scientific computing. In fact, suppose if I give say 3.679538, okay, doesn't matter how many decimal values you have provided here. Internally, maybe it is storing 679538001 or 3.6795379999. It will store one of them, not 538 exactly. Okay, or maybe even but the margin can be even higher. So how many digits are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the power minus 9 will be sufficient, right? Or maybe it can be 8 1, or it can be 7 9, and so on. But at least the experiments that we have made, 10 to the power minus 9 is sufficient for the technique. Okay.
Okay, sir.
Any other query? Okay. Now about the break. What is the importance of this break? As I said, suppose you are giving 3. Now, whenever I'll give 3, remember, it will not come here. Maybe you can remove break from here as well, but that will not affect this way if I give 3, because when I'm giving 3, it will jump directly here. Okay, and it will print 3. Now there is no break, and observe what I've written here. Execution starts from a case and executes up to the first break it encounters. So printf 3 will be done, printf 4 will be done, then there is a break, so it will print both 3 and 4. Okay, let me remove this one. It is giving me some distracting output. So it is giving me both 3 and 4. So does not matter whether you have break or not break all the previous cases, because whenever you're giving 3, it is jumping directly here. This is not even being checked. So 3, 4 will be executed one after another. Now remove this break. It will give you now 3, 4, 5. Okay, and if you give 4, it will give you 4, 5. This is called switch case fall through. Okay, so that's what happens when you do not give break. It has both advantages and disadvantages. Disadvantage is that you have to provide the break forcefully, and advantage is that it lets you to use further expressions in switch case. How is like that? Suppose int a is here, maybe you have assigned something or reading from user. Now if you want to do something like, say, if a is equal to 2, maybe you are doing b1. Else if a is equal to 3, or a is equal to 4, or more specifically else if a less than is equal to 4, you are doing b2. You cannot use less than is equal to directly or such expressions in switch case, right? Rather, now this can be represented in switch case as well. How? Suppose in the case of case 2, you are going to print printf2, whereas for case 3 and 4, maybe you are going to print say more than 2, and here also you want to print more than 2. Let me remove the rest of them. Default is optional. Now see, in the case of both 3 and 4, you have to provided the same block. You had to repeat the same block. Okay, obviously you have to provide the corresponding break here, otherwise it will print more than 2 twice if you give 3 input. But the fact is, due to the switch case fall through, it is sufficient to give this block only once. It is a small block, that's why you are not being able to see the difference. But if this case is a huge block and you want to execute this huge block b2 on both 3 and 4, that will be a problem. So in that case, simply remove this. I have removed the content of case 3 altogether. Okay. Now execute this. Oh, I have not given the semicolon. Now execute this. If 2, 2 got printed. If I give 3, observe that more than 2 got printed. Because fall through happened, right? When case 3 occurred, as there is nothing here, not even break, it fell through the case 4 and more than 2 got printed. And for 4 as well, more than 2 will be printed. So it is giving you the exact behavior, similar behavior like this. So if you want to execute certain block, where did it go? Okay, here. So if you want to execute certain block on multiple values together, this switch case fall through will help you. Is it clear? Is the concept clear?
Yes.
Whatever is said here? Okay. So that was everything about switch case. So if, else, if, switch case, all these things are done. Any query regarding today's discussion? In the next class, I'll start for loop and I'll end for loop as well. That means for while and the complete loop. And I guess if you give me the next Sunday as well, I'll start pointer by then. Okay. Any query? Any query regarding today's discussion?
Hello.
हाँ बोलो.
Sir, generally,
Your voice is too low.
Sir, can you briefly again explain that decimal case in switch case?
Okay. See, suppose rather than 3 here, I'm giving here say 3.8. Okay. Now, even if you provide the value of a as 3.8, okay, it will never be able to match with 3.8 because floating point numbers never match for equality. That I have shown, right? Floating point values never match for equality. Okay, first of all, it will never match for equality. So that's why, and secondly, the main reason is that the case values are used in an expression suppose I am giving it h, the function is hx, to calculate memory address. Okay, I have given this name hx because in algorithm it is a pretty common way to write hash function, but I'm not going into that much details. At least some expression is used to calculate the memory address. Now suppose I'm writing switch, say A. I'm writing case 2 sum B1 is being executed, case 3 B2 is being executed, and so on. Now in the memory, suppose this B1 block is residing here. Maybe its memory address is something, say 1230, something, anything. And just at its continuation, B2 is here, and suppose it is at address say 13A5. All are in hexadecimal. So that's why you're seeing this A. You can see the alphabets from A to F as well. Now, the fact is, H2, the hash is selected in such a way that H2 will be this and H3 will be this. Sorry, 13A5. And whenever, say, user has provided the value of A is equal to 3, that hash will be used on 3 and this address will be calculated and the control will jump directly here. Okay. Now, if you provide say case 4.5, this is a mathematical expression. Okay, hash value in fact it is a very detailed and deep mathematical expression. Now, if it is a floating point number, does not matter whatever expression you are going to use, that will always produce a floating point number, isn't it? Any operation that includes a real number always produces a real number. Especially in programming, because maybe if you are doing say 4.5 minus 2.5, but exact 4.5 and 2.5 are not being subtracted, right? Two floating point numbers, whenever you are doing the operation between them, it is always generating a floating point number. Is it clear till now? Whatever
Yes,
is said?
sir.
Now,
Yes, sir. Yes, sir.
memory address cannot be floating point real number, right? Memory address is always an integer.
Yes, sir.
So that's why these are the two regions that floating point numbers are never allowed in switch case.
Yes, sir. I
Okay.
got it. Thank you, sir. Yes, sir.
Any other query?
Sir,
Hello.
sir, am I audible now, sir?
Yeah, yes.
Sir, before I was asking that, sir, if generally more number of cases are there, people generally prefer writing switch rather than using if else.
Yes.
Is
Yes.
this assertion correct, sir?
Yes, you are absolutely right.
Yes.
Because generally the count is, it varies. I have seen some programmers writing switch case even with two conditions. I have seen programmers you uh, who use switch case when it crosses 5 number of cases. But the fact is, when you have small number of cases, if we consider from the viewpoint of the underlying how it is executing, when you have very small number of cases, you do not see much performance improvement, even though in the case of if it is executing each condition one after another, in the switch it is jumping directly to that address, avoiding all the previous conditions checking, but performance improvement is not much. Okay, from performance improvement of switch case is not much over if else if the number of conditions is small, say 3 or 4 conditions are there only. But when you have huge number of conditions, rather in those cases, readability of if else if is much better than switch case. Are you with me till now? Can you understand whatever I'm saying?
Sir, performance means with respect to time, sir?
Yes, with respect to time. Okay. Now, when you have much higher number of else, if else and such cases, it has to go through each case. In the case of if else if, it has to go through each case one after another, each condition one after another, right? And if you have say 20 or 30 cases, 20 or 30 conditions like that, it starts showing some performance penalty over switch case where it can jump directly to maybe the corresponding case. Is it clear whatever is said? Suppose if there are 20 to 30 cases here and maybe the user have provided the last case here, A have been provided as 50. But before coming to this case, what else will do is that it will check each and every case one after another. That will give you some, that will require some bit higher amount of time. Okay, whereas in the switch case, it will jump directly to case 50. It will jump directly to case 50. So which one is faster? In that case,
switch case.
Switch case. So that's why switch case is used when the number of cases become sufficiently large. Okay. Does it answer your question?
Almost, sir.
Okay.
Sir, I just want to see that program in which it will show the time difference, sir.
Writing such program is difficult because firstly you have to provide huge number of cases, okay, and you have to provide the huge number of cases here as well.
Sir, if I give cases, can you write?
I think you can write that as well. You can check it out. Okay, why don't you check it out and let us know in the next class, because
Sir,
it will take time.
Sir, I know how to write, build up many cases, but I don't know how to print the time difference.
Okay. Let me show that. You
Sir,
just
you can show it in the next class if time is more, sir.
Okay, see. What am I doing here? I think I have done some. Yes, this one. Suppose you have compiled this, then use time comment, then corresponding a dot out. Okay, let me give some fixed value here. Time comment in the Linux will give you.
Sir, I don't have that Linux.
Okay, I do not know how to do it on Windows. I'm sorry for that, but I'll check it out how to do that on Windows. Then I'll let you know.
Okay.
Okay.
Sir, thank you, sir.
Welcome.
So please upload the notes.
Yes, I'll upload the notes today because a lot has been taught today. I'll upload the notes to both D and section E, to both of your sections.
Sir, and previous ones also, sir, from after the introduction part.
In fact, I'll upload. Yes, I'll upload all the notes. That means I'll convert all the notes to PDF in one swipe and upload them.
So, or you can share that OneNote's a link for it, sir.
OneNote link. Let me see how can share that. If we can share it, that will be in fact the most shortcut way. I think yes, this can be shared. Yes, this can be shared. This is for D, but do not edit this. Now, for section D, what is your email ID? Do you have any email ID for section D? This for computer programming D.
Okay.
Huh?
Sir, individuals have email ID.
Okay.
Try
There is a copy
and
link.
paste
Yes,
it
there
in
is a
chat
copy link.
section.
There is a copy link. This is in fact much better because I generally need to switch some Windows machine because my machine do not have Windows. This is for D. Okay, so I'll upload it for your section as well, for section E like this. But some of you kindly tell me whether it is accessible. Someone check that out and tell me whether it is accessible and whether the complete one is accessible.
Sir, I think not accessible.
Not accessible?
Yes, sir. It is showing the page is not working right now.
Sir, for me it is showing firewall or antivirus software may have blocked the connection.
Okay. Okay, then in that case I'll have to convert it into the PDF.
Sir,
But
no,
still
sir, it's working, sir. In phone, I have tried it and it's working.
Then I think on your Windows machine some firewall is
Some settings have to be changed. Security
you
settings.
have to change some settings. It is for section E.
That is working.
If that's working and if you have Windows machine, can you kindly convert that to PDF? I think you can convert that to PDF in that case, or I'll have to find some Windows machine. Okay, I'll find this one. If it is not working for some of you, I'll convert it to the PDF file as well. But we'll check that out. Is for the computer programming part, which I have taught in as common today, and also in the next Sunday I'll teach as common. For those who have access to this, can you tell me that whether the complete part is accessible?
Yes, sir. All the complete part.
Okay.
Yes, sir. Read-only access.
Yes, I have created read-only access. But whether everything is accessible there. This is for what I have.
Yes, sir. Like in folder section, like you created introduction, C programming.
Okay. Yes. This is for E. To this general part went, and this is for D. Okay, done. Okay, so we'll see you. I think section D. I have a question for you. Tomorrow is holiday, I think. Would you like to do the class?
Sir, how many hours?
No, sir, tomorrow no.
Tomorrow at 11 to 12. Oh no, sorry. Tomorrow is E. Yes, to section E. Would you like to do the class tomorrow?
Sir, how many hours?
You
How
can
many
discuss
hours
among
tomorrow?
yourselves. Tomorrow is from 11 to 12 and then from 5 to 6. You discuss among yourselves and let me know. I have no problem in taking class. Okay. Okay.
Sir,
Okay.
after allowing everyone to leave, can you please give me 5 minutes?
Okay, you can ask now as well, because our discussion is done. So those who want to leave, you may leave. Bharat, you can ask your question.
Sir, not a question, sir. Can you please brief me what you taught in the first half?
Okay.
Thank you, sir. Sir, we can leave?
Yeah, sure. Okay. In the first half.
Thank you, sir.
Welcome.
Thank you, sir.
Sir, before that example of leap year.
Okay. Before the example of leap year, what I've discussed here is firstly not C1 and then C2. I think you can refer to the recording as well, but still let me tell you. Not C1 and then C2 gives you not C1 or not C2, and not C1 or C2 gives you not C1 and C2. These conditions are important. Abhijit, kindly mute yourself. Okay. Now, then I have discussed about the basic structure of if condition, if B1 will be executed only if the condition is true. Okay. And then I have shown certain example here. As an example, if I execute this part, this line will execute unconditionally. Hello will be printed. Suppose A is 5. A is 5 here initially. So hello will be printed here. This condition becomes true. So this will be printed, and then this line will be printed unconditionally again. But if I convert it to 3, then this line is unconditional. So hello will be printed, but this condition is false. So this line will not be printed. In fact, this block gets printed only if this condition is true. Otherwise, this block is not printed. Then this line gets printed unconditionally again. Now, then, in fact, else is optional. But if you include else, B1 will be executed. B1 will be executed only if condition is true. Otherwise, if condition is false, B2 will be executed. And then I have shown certain examples here. Okay, I have removed those examples, but
Sir, you can leave those examples.
Okay. Now, next, what I've shown here, in fact, a discussion about strings and all those parts happens. That what happens that if you print, say, suppose you have taken A is equal to 5, B is equal to 0, then I got a question that if you print as %s, in fact, what I observed there was null appeared. But why that happened? Because eventually these numbers represent the memory address. Whenever you are using %s, the printf will treat these numbers as memory address. And there was nothing, there is no string at this memory address A is equal to 5. So that's why you are seeing null, but it is compiler dependent. Okay. Then after that, if else, then we are back on track on our original discussion. If else, similarly, rather than discussing about only C1, rather than checking on only C1 case, if you want to check multiple cases, in that case, there is else if. So if C1 is true, B1 will be executed. Otherwise, if C1 is false and C2 is true, right? You do not need to write else if not C1 and C2. It is not necessary to write. When it is coming to else if, it is already well known that C1 is false. So if C1 is false and C2 is true, B2 will be executed. Now after checking these two, if it is here, that means C1 and C2 both have turned out to be false. That's why it is here, C3. Okay. And so if C3 is true, but both C1 and C2 are false, then B3 will be executed. Otherwise, if all C1 and C2 and C3 are false, then B4 will be executed. And then here I have shown as an example that suppose if you write A less than 100 here. Okay, let me remove them, or let me write this here as well. Suppose if you are writing else if A less than 100, then if you provide say 4, okay, 4 is already less than 100, so B1 will be executed and none of the other cases will be checked. Now if you provide in this case, right, now suppose if you provide 12, this case is false, so it comes here. This case is true, so B2 will be executed. Right? Now if you provide 134, this case is false, this is false, then it will come here. Suppose this is 1000. It is true here, so B3 will be executed, and so on. So that's why it is always important to write these conditions in sequence. If you provide 1000 here, and if you provide only 100 here, this B3 would never be executed, because in the case of 4, B1 is executed, that's right. But in the case of say 12, it is false here, it comes here. This condition is true, so B2 will be executed. And it will simply go out of this. B3 and B4 will never be executed. Even also case of 134, this case is true. So B2 will be executed. B3 will never be executed. But if you write some complex expressions like a greater than is equal to 100 and a less than 1000, then in the case of 12, B3 will be executed, right? Because in the case of 12, this condition is false, so it will come here. Now 12 greater than is equal to 100, this condition is false, so it will come here, right? Now this condition is true because 12 is less than 100, so B3 will be executed then. Whereas for the case of 134, this condition is false, but this condition is true. 134 is greater than 100 and less than 1000, so B2 will be executed. So that
Sir,
will give you your normal execution again. Ha, bolo.
does that mean that we can print complex condition in any format?
Yes, obviously.
Okay.
You can always provide any type of complex conditions. But what will happen is that this, though this gives you your normal execution again, but it leads you to write some complex conditions, which in fact would not be necessary if you would have written them in proper sequence. So rather than writing such conditions, always prefer to write in proper sequence. You'll see that your writing amount will be lesser. Okay.
Okay, sir.
And then we have discussed about block within block. If C1 is true, then it will enter here. Then within this, it will check for the truthfulness or falseness of C2. Otherwise, if C1 is false, it will enter here. Then it will check the truthfulness or falseness of C3 and will execute the corresponding block correspondingly. And then we have appeared here in ternary condition, okay, which is the if else's equivalence. If condition is true, B1 will be executed. Otherwise, if condition is false, B2 will be executed. And after that, I have started with the play pair example.
Okay, sir. Thank you, sir.
Welcome.
Sir,
Bolo.
Sir, I have a small doubt, but not today's lecture. Can I ask?
Yeah, sure.
Sir, I did not understand, sir. What is the mean of a return, sir? What is the use of, sir? Sometime I did not write return, but program is executes. Sir, can you?
See, if I use int main and in the case of if you do not provide return 0 here, there will not be a problem in the case of int main, though it is always good practice to write return 0. But if you do not write return 0, as main is a special function, operating system invokes it directly. When it ends after executing successfully up to this, it by default is considered that it returns 0 for successful termination. So you may omit for main function, but when you write return 0 means this value is returned to the kernel. That means the operating system. Okay, to determine whether it was successful or not. If 0 has been returned, then the program execution is successful. If you return any other value, the kernel will think that your program terminated abnormally. Okay, so in fact, in general, return statement is used to return from a function. That means, suppose in the main, if you invoke some function, say f, okay, and f should be defined above main in that case, or at least declared above main. I'll discuss it when we'll discuss about the function. Now, if you write return 5, okay, so if main is invoking f, when f will return, it will return back to main, and when it will return back, it will return with this value 5. Okay, and you can catch this value in a variable as well. So after this line, a will get 5. But this is for internal functions. When one function is invoking another function, whatever value the called function returns, the caller function gets that value. Is it clear till now?
Yes, sir. Yes, sir.
Okay. But in the case of main function, no one invokes main function, right? Main function is the entry point. It is only operating system, that means the kernel itself, that invokes this main function. So whatever it is returning to the kernel, to your operating system. And operating system is using this value to identify whether your program has been terminated successfully or abnormally. Okay. So this is being returned, return value of main is returned to OS directly. Okay, how it is returned, what happens within OS, I am not going into the details. When you study about the operating system, you will go into depth of this. But if I start discussing about this, it will take another 3 or 4 hours. Okay, but it goes to the OS directly, and OS from this value identifies whether your process, whether your program, I think you can understand process now from the study of process management, whether your process has terminated abnormally or successfully. Does it answer your question?
Yes, sir. Yes, sir. And sir, if void main, then sir, starting
It
when
by default returns 0. Okay.
oh,
In the case of
thank you,
void
sir.
main, if you want to represent some abnormal termination, in that case there is a special function that is called exit. Okay, that means suppose if you wish to write void main, and after some condition, maybe user has provided some erroneous condition, and based upon that you want to tell that user has given some devastating input, and I have to exit from here. In the case of int main, you write return 1 here. In the case of void main, write exit within bracket 1 here. But to use this exit, you have to use the stdlib.h header file, because this exit function is defined in stdlib.h header file. And this exit function again exits to the operating system with whatever value we are passing here as a parameter to represent whether your program terminated abnormally or successfully. Okay. Is it clear?
Okay, sir. Thank you, sir.
Welcome.
Sir.
Yes, sir. Yes, sir. Yes, sir.
Bolo.
Sir, to terminate infinite loop, any special key can be used?
Control C.
Okay, sir. Okay.
Any other
Thank
query?
you, sir.
Welcome.
No, sir. Thank you.
Okay. So I'm stopping the sharing. I'm stopping the recording. We'll see you.